So good evening everybody. So this is a today's paper RPT1, which is on unit dimensions and measurements. So let's talk about a paper and let's solve as soon as possible. Right. Where I have to keep it. 1 second. Right. So first question is, there are 10 divisions on the main scale of Vernier calipers coincide with the 12 divisions of Vernier scale. If each division on a main scale is of 2 units, then we have to find out a least count is. So question is, there are 10 divisions on a Vernier calipers which are coinciding with the 12 divisions of a Vernier scale. And the second logic is, if each division of a main scale is 2 units of a least count. 2 units, then we have to find out a least count. So we know that logic or a formula. We know the formula for this least count is, we know that least count is equal to, we have a least count can be written as MSD minus VSD, right? So MSD minus we have a VSD, and saying that 10 divisions of a main scale of a Vernier calipers coincide with the 12 divisions of a Vernier scale. So it's saying logic number, let's say 2 anukondi. So it's saying that 12 Vernier scale divisions are coinciding with the 10 main scale divisions, right? Therefore we have a 1 MSD or we have a 1 VSD is equal to 10 by 12 MSD. If we cancel out this, it is nothing but a 5 and a 6. Therefore we have a VSD is equal to 5 by 6 MSD. VSD is equal to, we have a 5 by 6 MSD. Therefore we have a least count. Therefore we have a least count is equal to MSD minus VSD. So we have a MSD minus VSD can be written as a 5 by 6 MSD, right? Therefore we can write as a 6 minus 5, nothing but I have a 1 by 6 MSD, right? Therefore here MSD is given as a 2 units. Therefore we can write as a 2 by 6, that will be equal to 1 by 3. So therefore the answer is, therefore we have a answer is 1 by 3. And this is the right answer for this. That's answer for 1 by 3. Clear? So next question. The next question is, we have to match a list 1 and a list 2. There are quantities on left side and there are dimensions on the right side. We have to match them. The first one is the capacitance. Second one is the permittivity of free space epsilon naught. Second one is the permittivity of free space mu naught, and we have a electric field, right? So hope you understand the first question. So let me clear it. So coming to the capacitance, you know the capacitance formula. So we know the capacitance formula. We have a capacitance is equal to, we can write as, or else let me say basic formula of capacitance. That is, we have a, you can write as a Q is equal to CV, right? Therefore you can write the C is equal to Q by V, and you can write the C is equal to, Q can be written as current into time, and V can be written as, you can write as a W, or else wait, we can do it in a easy way. We can do it in a easy way without converting that. So capacitance can be written as a Q by V. Can write as a Q here, and voltage can be written as a W by charge, work per a charge. Therefore I have a C is equal to, we can write as a Q square by W. So C is equal to Q square by W. I have a C is equal to, Q can be written as current into time. Therefore I can write as a ampere square, and I can write as a time, nothing but ampere square or second square. I could say, ampere square and a second square by this can be written as a work can be written as, you guys know that, like kilogram meter square, and we can write as a per second square we can write for a work. Therefore the answer will be equal to, we have a m power minus 1, we have a L power minus 2, and we have a T power minus 4, and we have a square. So m power minus 1, L power minus 2, T power minus 4, and a square. M power minus 1, L power minus 2, T power minus 4, and a square. So therefore for the capacitance, that might be third option. That might be third option. So that is a 3. So we have a A3, that means we can eliminate this fourth option and the third option. So we have to go for the either A3 or we have to go with the A or a B. And now coming to the electric field, and we can do this electric field as you know the electric field formula, that is I have a voltage equal to we have a E into D, right? So this voltage can be written as, just I told you, that is work for a charge will be equal to we have a E into D, right? Therefore I have a E is equal to, we can write the W by or work by, we can write the Q into D. We know that work is nothing but M L square, we have a T power minus 2 by Q can be written as a like I into T, nothing but we can add the ampere or else into second, nothing but I have a T into I have a length. Therefore this one get cancelled. Therefore we have a M L, so that will be like a T power minus 3 and I have a power minus 1. So ml T power minus 3 a power minus 1, so which is nothing but a D1. Therefore option is right, option A is right. So that is for a second one, right? So third one, in a third one given below are two statements. One is labeled as assertion and other one is labeled as reason. In a Vernier assertion is, in a Vernier caliper, if a positive zero exists, then while taking a measurement the reading has to be more than the actual reading. Yeah, that's, you know that already. And next, the zero error in a Vernier calipers might have happened due to the manufacturing defect or due to the rough handling. Yeah, this is also right, which is also right. So due to the rough handling and manufacturing defect there is a error, but this should not, I mean the reason is should not correct for assertion. So if anybody asks why we are adding when there is a positive error ante, we could not say that like rough ga handle cheyadam valla nu add chestam ani cheppalem kada. So kabatti rendu right, assertion right as well as the reasoning kuda right, but reasoning is not good explanation for a assertion. Therefore answer is first one, both assertion and reasoning are correct and reason is the correct explanation. No, reason correct explanation kaadu, both assertion and reasons are correct, but reason is a not correct explanation. So this is answer for a fourth one. So this is the answer for a third question. Next, if the length of the pendulum in a pendulum clock is increased by 0.1%, then error in a time per day is. If the length of the pendulum is increased by, so length is increased by, so this length is increased by, the length of a pendulum is increased by 0.1%. Now we have to find error in a time per day. So error in a time per day, that we have to calculate, and you know the time period formula, right? So the time period formula is, when the time period formula, we have a time period formula is equal to E is equal to 2 pi, we have a under root of L by G, right? So if you check the error for this, you can write as a delta T by T. We have a delta T by T can be written as, you can write as a 1 by 2, you can write as a delta L by L, right? So you know that percentage of this one, that is I have a delta T, I have a delta T by T into 100 will be equal to, we have a half into we have a delta L by L into 100, and you know this value of this, you know the value of this, that is given as 0.1. Therefore we have a delta T by T into 100 will be equal to, we have a half into 0.1, and we can also write as this delta T. We have a delta T is equal to like 0.1 by 2 into I have a time by I have a 100. So for a 1 day the time will be like, I can add the 0.1 into like 24 hours 60 minutes and 60 seconds by, I can write it as 100. Therefore if you do this calculation you will get answer, that is you will get it as 43.2 seconds. That's answer for this. So that's the answer for this one, that is 43.2. so check it once, right? That's answer. So let me go with the fifth one. if a unit of length and time is a double, the numerical value of a g. So it's all about a unit conversion. So that's one is easy. So let me clear that fourth one. Right. So fifth one, if a unit of length and time is double, the numerical value of a g. So let's solve it. So normally we know the g, that is I have a g is equal to kilogram, which is acceleration, sorry, that is for meter per second square. Therefore I can add the LT power minus 2. So now therefore we have to change the units. So let's say there are two units, n1 u1 is equal to, we have a n2 u2, right? Clear. So let's say this is a SI unit. So let's say it is a 1 unit I am taking here, that is a g, and this units can be written as LT power minus 2 here. And I don't know this number of units in a dummy units, and I have a this can be written as in a dummy units, that can be written as I have a L dash by I can add as a T dash square, right? Therefore I can add as a L T power minus 2 will be equal to I have a N2. L dash can be written as length is double, therefore you can add the 2 times of L by, and the time is double, therefore you can add the 4T square. Therefore this LT power minus 2 and this L and this T square cancel, therefore this also cancel, therefore this N2 will be equal to 2. We have a N2 is equal to 2, therefore the value of G in a dummy units will be doubled. So that is answer fifth one. That's the answer for the fifth question. That was the answer for the fifth question, right? So let me clear it. That was the answer for the fifth question. So next one is the sixth one. A student is provided with a variable voltage V, a test resistor. There is a test resistor which is having 10 ohms. There is a test resistor having 10 ohms, and there is a two identical galvanometers G1 and G2, and two additional resistors. One is 10 mega ohms and other one is a 0.01. That is, one is having a high voltage, other one is having a low voltage. For a conduction, an experiment to verify the Ohm's law, the most suitable circuit is. So you guys know that how to convert this galvanometer into a meter as well as a voltmeter, right? So if you wish to convert this galvanometer into a meter as well as a voltmeter, there is a logic that let me 1 second. Right. So let's say what I'm doing, I'm just converting this galvanometer into So I'm just converting this galvanometer into a meter. So let's say it is a G. Let's say it is a G, nothing but galvanometer. Now I wish to convert. Now if I wish to convert that into a meter, I have to connect a resistor over here which is having a low resistance, nothing but I have to connect it as a R2. So if I connect it as a R2, that will become a what? That will become a ammeter. And now in the same way, for example, let's say don't want to waste my time. If I want to convert that into a meter, I have to connect a resistance which is having a high voltage in a series with it. Then it will become a voltmeter. Then that will become a voltmeter. So that is ammeter as well as a voltmeter. Now have a look. So now which is a voltmeter and which is a ammeter? For example, let's say in a first case, I have a G1 and R2. I have a G1 and R2. If I connect this R2, if I connect that R2, now I know this will act as a ammeter. This will one second. So this part. So this part will act as a ammeter. That part will act as ammeter because we are connecting a low resistance in parallel to the galvanometer. So that will act as what? Ammeter. So this will act as ammeter, and now this part will act as a voltmeter. But నార్మల్గా మనం కనెక్షన్ చేసేటప్పుడు అమ్మీటర్ని ఎప్పుడు కూడా సిరీస్లో కలపాలి, వోల్ట్మీటర్ని ప్యారలల్గా కలపాలి. వోల్టీమీటర్ని ప్యారల్ కలపాలి. దెర్ఫోర్ ఇది అమ్మీటర్, ఇది వోల్టీమీటర్, బట్ కనెక్షన్ రాంగ్ ఉంది. కనెక్షన్ ఏం రాంగ్ ఉంది అంటే అమ్మీటర్ ప్యారల్లో ఉంది, వోల్టీమీటర్ సిరీస్లో ఉంది, కాబట్టి దిస్ వన్ ఈజ్ అ రాంగ్, ఇది రాంగ్ ఇది. అండ్ కమింగ్ టు ద సెకండ్ వన్, సో వీఆర్ కనెక్టింగ్ హై రెసిస్టెన్స్ ఉన్న దాన్ని ప్యారల్లో కలుపుతున్నాం. హై రెసిస్టెన్స్ ఉన్నదాన్ని ప్యారల్లో కలిపితే ఇట్ ఈజ్ నైదర్ వోల్టీమీటర్ నార్ అమ్మీటర్. అండ్ ఇక్కడ లో రెసిస్టెన్స్ ఉన్న సిరీస్లో కలపడం, సో ఇట్ ఈజ్ నైదర్ అమ్మీటర్ నార్ వోల్టీమీటర్. నార్మల్గా ఇక్కడ అంటే ఓన్లీ కనెక్షనే రాంగ్, బట్ ఇక్కడ ఇట్ ఈస్ నాట్ ఈవెన్ యాక్టింగ్ యాజ్ అ అమ్మీటర్ అండ్ వోల్టీమీటర్, రెండు కింద యాక్ట్ అవ్వవు. అండ్ కమింగ్ టు థర్డ్ కేస్లో గాల్వనోమీటర్ ఉంది, R1 ఉంది, నథింగ్ బట్ గాల్వనోమీటర్కి హై వోల్టేజ్ కలుపుతున్నాం. గాల్వనోమీటర్కి వీఆర్ కనెక్టింగ్ అ హై వోల్టేజ్, సో దిస్ పార్ట్ విల్ యాక్ట్ యాజ్ అ వోల్టీమీటర్. Now that will act as a voltmeter and this part will act as a ammeter, right? This part will act as a ammeter. So now this will act as a voltmeter and this will act as a ammeter. And voltmeter ni parallel kalpunam, ammeter ni series lo kalpunam. Therefore, the option C is right. And here G1 and R2. So G1, R2 as well as ikkada both rendu kuda parallel kalpunam kabatti, so this will act as a ammeter, right? But this won't act as a ammeter. So therefore, that fourth option is wrong. Option is right. Option C is right for a sixth question. Option C is right for a sixth question. I think that's clear for everybody. గాల్వనోమీటర్ని అమ్మీటర్లో మార్చాలంటే లో రెసిస్టెన్స్ ఉన్నదాన్ని ప్యారల్ కలపాలి, అండ్ గాల్వనోమీటర్ని వోల్టీమీటర్ కలపాలంటే హై రెసిస్టెన్స్ ఉన్నదాన్ని సిరీస్లో కలపాలి. సో దట్స్ ఫర్ సిక్స్త్ క్వశ్చన్. హోప్ దట్స్ క్లియర్. రైట్, సీ ద నెక్స్ట్ క్వశ్చన్. In an experiment, on the measuring of a G using a simple pendulum, the time period was measured with an accuracy of 0.2%, while the length was measured with an accuracy of 0.5%, the percentage accuracy of a G. So easy question, hope you guys already చేశారు అనుకుంటున్నా. So the time period with accuracy of 0.2% and the length with an accuracy of 0.5%, then we have to find out accuracy percentage of accuracy in a G. So you know the direct formula. Let's say we have a time is equal to 2 pi under root of L by G. That's a basic formula, right? Therefore we can write as I want to find out a G, therefore we can write as the T square is equal to 4 pi square, we have a L by G. Therefore I have a G is equal to, you could say that is nothing but L 4 pi square by T square. Therefore this can be written as I have a delta G by G will be equal to, you can write as a delta L by L plus we have a 2 into delta T by T. 2 into delta T by T, we have to find out a percentage of it. Therefore we have to take it as a into 100. Consider that into 100. So if you consider that into 100, this will be like 0.5 plus this will be nothing but a 2 into 0.2, that will be equal to 0.9, right? So option D is right for a seventh question. Hope that's clear for everybody, right? So this one, question number 8. In an experiment to determine the focal length of a concave mirror by the UV method, a student placed the object pin A on the principal axis at a distance x from the pole P. The student looks at the pin and its inverted image from a distance keeping the eye in a line with the PA. When the student shifts the eye towards the left, the image appears to the right of the object on the pin. Then what? Then we have to find whether x is less than f is less than x is less than 2f, x is equal to f and x is greater than 2f. For that we need to understand the diagram first. Let's draw the diagram and let's try to understand. Right. So let's say it's a lens. Sorry, that's a mirror. Let's say that's a mirror and let's say it's principal axis, and there is an object. So there is an object on the principal axis at a distance of x, right? There is a right? So which is at a distance of x. This object at a distance of x, at a distance of x, we don't know what is the distance is. Now if you look at object and this image is inverted and that is the right side, the image is inverted and that is the right side, so let it be the left side, let it be the right side. Now if he was looking at the image is forming on the right side, so let me draw the image. Image now, wait. So if I draw the image is somewhere here, right, like this. The image is somewhere here like this, so that is the image will be beyond object ante. The image is beyond object ante. There is only one case. The one case is, you guys already know that, this one, that is option B. Sorry, that is option B. Answer is option B. If the object is if the image is beyond object, if the image is beyond object, so we'll have only one case, that is this object should be in between a center of curvature ki and a focus ki madhyalo undali. Therefore the answer for our 8th question is the B, right? So that's clear, right? So next question number 9. In the equation x plus a by y square and y minus b equal to RT, x is the pressure, y is the volume, R is the universal gas constant and T is the temperature. The physical quantity equivalent to ratio a by b is. So you guys know this equation already. I think it seems like a previous year question, right? So this is an equation that was given, right? So let me solve it. We have equation as x plus a by y square into we have a y minus b, so equal to we have a RT, right? And he's saying two more things, that is x is the pressure, so he's saying one more thing, that is x is the pressure, y is the volume and T is the temperature, and remaining this a and b are a constant. Since x is the pressure, you know that already. This logic is according to this what, a principle of homogeneity. So same quantities ఉన్న వాటిని మాత్రమే మనం యాడ్ చేయగలం. అకార్డింగ్ టు ప్రిన్సిపల్ ఆఫ్ హోమోజెనిటీ, సేమ్ యూనిట్స్ ఉన్న వాటిని మాత్రమే మనం యాడ్ చేయగలం. Therefore these two must have a same, this x plus a by y square or x and a by y square should be have a same units. Same way y and b should have a same units. అప్పుడు మాత్రమే మనం వాటిని యాడ్ చేయగలం, లేకపోతే సబ్ట్రాక్ట్ చేయగలం. Therefore according to that principle of homogeneity logic, this x as well as this a by y square, they both are having same units. So x is the pressure, therefore we have a pressure is equal to, let me say this is a by y is a volume, so let me say it is a v square. Pressure formulas, force per area, force can be written as ml, right? We have a ml t power minus 2 by area nothing but we have a l square into we can write as a l cube, or else no need of it. There is, I have a by v square can be written as, I can write as a l cube, and I have l power 6. This one can cancel, I'll let with a l power 4 here, so I have a l power 5. Therefore I have a will be equal to m l power 5 t power minus 2, that is a, right? And what about a b? And here we know that y and b both are having a same dimension. Therefore we have a y is equal to b, and b is equal to volume, and b is equal to, I have a l cube. Therefore he is asking a by b. Therefore if I write it as a by b, that is I have a m l power 5 t power minus 2 by we have a l cube, that will be cancelled, that will be equal to m, I have a l square t power minus 2. ml square t power minus 2 are the units of dimensions of energy. Therefore the answer for this question is this one, that is option A, right? So that's for a option, that's for a 9th question. I think that's clear. Let me rub it. Right. So look at the 10th question. 10th question is, the specific heat of a liquid was measured by placing 100 grams of liquid in a calorimeter. The liquid was heated by an electric immersion coil. The heat capacity of the calorimeter together with the coil was previously determined by 31.4 joule per Kelvin with 100 grams of sample placed in the calorimeter. A current of 0.5 amperes was passed through the immersion coil for exactly 3 minutes. The voltage across the terminal of the coil was measured to be 1.50 volt. The temperature of the sample was, oh my god, it's a big question. Okay, let me find out the values. The specific heat of a liquid was measured by placing 100 grams of liquid. So we are having a mass of liquid as 100 grams, and the heat capacity of this calorimeter, the heat capacity of calorimeter was to be 31.4 with the 100 gram sample placed in the calorimeter. There is a current 0.5 ampere, and we are using it for 3 minutes, and we have a voltage too. The voltage is a 1.50, and there is a rise in a temperature, that is 0.5. Then we have to find out a specific heat of a liquid. We need to calculate a specific heat of a liquid. So these are the things that are, but here there is a energy conversion, that is this energy released by this current or electricity will be converted into the thermal heat. So that is a logic over here. Let's solve it. Therefore we know the heat formula due to this electricity, that is we have a I into V into T, or else power into time. Therefore we can write the H is equal to I can be written, I is given as a 0.5, and voltage can be written as a how much, 1.50, and we have a time is given as, time is what, 3 minutes, so nothing but we have a 3 into 60. So if you do this you will get some value, right? So 0.5 into 1.50 into 3 into 60, how much that will be? 0.5, 1.5, 3 into 60. So we have a 0.5, 3 into 60 into how much? That is 1.5. I have a 1.5. Therefore that will be like 135. So I have a this heat energy is a 135. Now this 135 will be converted into the heat energy, which is nothing but a Q, and we know that 135 will be equal to Q can be written as a ms delta T. We have a ms delta T. Therefore we have a 135 is equal to, that can be written as ms delta T. Ms delta T for this both, that is for a calorimeter as well as a calorimeter of specific and calorimeter, plus this is for the liquid ml as well as a SL as well as a delta TL. So since we know that here this heat capacity formula can be written as I have a Q is equal to ms delta T, right? From this we can write this delta T as, or we can write as a Q by delta T as a, we can write as a Q by delta T as a ms. So nothing but for a calorimeter this MSCS value will be equal to 3.14, that you need to understand. That will be equal to 3.14, that you need to 1.34, that has to be understand. Clear? Right? There is no space, I'm going up. So therefore I have a 135 will be equal to, I am writing it as a MCSC plus I have a MLSL into I have a delta T, right? Therefore I have a 135 will be equal to MCSC, this is given as a 31.4 plus I can write as a MLS 100 gram, that is 100 into 10 power minus 3 into I can write as a SL into delta T. The delta T will be equal to what? The delta T will be equal to 0.8. The delta T will be equal to 0.8. Therefore do this calculation for this cell and you will get an answer, right? So check it once. We are just converting heat energy into that thermal energy. So in a heat energy in a current velocity can be written as is equal to IVT, and therefore first we will find out this heat, and that heat will be converted into thermal heat. Therefore we have a 135 ms delta T, and there is a one more logic, that is this one, that is what, that is this heat capacity also, that is also important in order to find out that's ms and MCCSC, right? This one. So this one is important. Clear? So that's clear for everybody. Let's see question number 11. Let's see the question number 11. Right. Let's see the question number 11. In experiment to measure the focal length of a convex lens, the least count of the measuring scales for the position of object U and for the position of image V or delta U and delta V respectively, the error in the measurement of the focal length. So you guys know the focal length formula. You guys know the focal length formula, right? What is the focal length formula? So focal length formula can be written as, we have a 1 by F equal to, we can write as a 1 by V minus we have a 1 by U, right? Therefore if I just differentiate on the both sides, if I differentiate on the both sides, that will be equal to, we can write as a delta F by, we have a F square will be equal to, we can write as a delta V by, we have a V square, plus we have a delta U by U square. Though there is a minus, we are just add because to get a maximum error. Therefore we have a delta F equal to, we have a F square into delta V by V square, plus we have a delta U by U square. That's the answer for the error in a focal length, right? So the answer will be like F square into delta U by U square plus delta V by V square. The answer is this one, that is the option B. So that's the question number 11. That was the question number 11. Clear? So let's move to the next one. So question number 18, you just do it. Question number 18, right? And question number 19, which of the following units denotes the dimensions of a ml square q square, where q denotes the electric charge. So seems somewhat tough. And that question number 18, so you guys do that. Look at this question number 19. So that is a given, that is ml square by q square. So ml square, they both are dimensions, and a q square can be written as a square and a t square. Therefore we have a m l square by, we have a q square. Therefore we have a m l square by q square can be written as a square, and it can write as a t square. That will be equal to m l square a power minus 2 t power minus 2. That was the ml square by q square. And we have to cross check which of these them will have a same units as this one. Let's say Weber per meter square. Weber per meter square is nothing but a magnetic field. Weber square meter square is nothing but a magnetic field. So you know the B formula, so that is for a B. This can be written as from force, that is force is equal to, you can write as a B into I into L. Therefore you can write it as like a B is equal to force by, I can write as a I into L. Force can be written as M L t power minus 2, I have a power minus 1, and by L this will be cancelled. Therefore I have a m t power minus 2, I have a power minus 1. This will be by L, right? So therefore this is m t power minus 2, a power minus 1. Therefore it is not a right answer. And let's go with a Weber. So Weber is nothing but a flux. For a flux can be written as, you know the flux is equal to B into A. You know the B is nothing but m t power minus 2 a power minus 1, and area can be written as a L square. That can be written as a m L square t power minus 2 allow a power 1. Therefore again that is not matching, right? Again that is not matching, so therefore not even this one. Easy goda gadu. Coming to the Henry can be written as a self-inductance. Henry can be written as a self-inductance. So self-inductance formula, we have a pi is equal to L into Y. We have a pi is equal to L into Y. Pi can be written as m L square t power minus 2 a power is how much? For a B, a power minus 1, right? Therefore this is a power minus 1. And here I have a ml square t power minus 2, I have a power minus 1. That is what? That is for the flux. Into I have a L into A. If this A comes on the left side, that will be equal to, therefore I have a H is equal to Henry m L square t power minus 2, I have a power minus 2. Therefore that is matching with this ml square a power minus 2 t power minus 2. Therefore the answer is this one, that is a Henry. The answer is that one. Therefore, answer for this 19th question is answer for the 19th question is Henry. Clear? What about answer for our 20th question? While measuring the speed of a sound by performing a resonance column experiment, a student gets the first resonance condition at a column length of 18 cm during a winter. So first resonance is occur. So first resonance was occurred at 18 centimeter in a winter, and the second resonance was occurred during a summer, that was at x centimeter. We have to find out that x range. We need to find out that x range. So this is a resonance column tube experiment where we will find out a speed of a sound. I told you already in this class. Therefore, there are the two resonance cases. One is a first resonance, second one is a second resonance. You know that second resonance will be hard at a third harmonic, right? So let me clear this. So listen. So let's say you know that resonance, both are resonances. Therefore, both will have a same frequency. That is, will have a first frequency as well as first harmonic, third harmonic. They both will be same because the resonance is same. That is nothing but the resonance will be equal to tuning 4. So we know that first resonance will be occurred at V by 4L, and we know that third resonance will be occurred at 3V by 4L. You guys already know this logic solve. So 3V by 4L. Therefore, the resonance, it is a resonance. So therefore, frequency will be same. Nothing but we can we can equate this both. 4 into L is equal to, I have a 3V by 4 into this L is given as a X. Therefore, this VV get cancelled and 4 also get cancelled. Therefore, we have X is equal to 3 into length is given as in a first resonance 18. Therefore, I have a X is equal to 54 centimeter. That has to come. So X has to come exactly 54, but due to the summer, this might be somewhat greater than 54. Therefore, the answer is this one. That is, X should be greater than a 54. Therefore, X should be greater than a 54. That's a logic. Clear? Right? Over here. Right. So, 1 second. Question number 21. Look at the question number 21. 2 full tons of the circular scale of a screw gauge cover a distance of 1 mm on its main scale. The total number of divisions on the circular scale is 50. Further, it is found that the screw gauge has a zero error of minus 0.03 mm. While measuring the diameter of a thin wire, a student notes the main scale reading of 3 mm and number of circular scale divisions in a line with the main scale as 35. The diameter of the wire is d mm. The value of 100 you have to calculate. So let me see what are the given things. 2 full tons. There are 2 full tons that you need to understand. 2 full tons of a circular scale of a screw gauge cover a distance of 1 mm. Therefore, it is not a pitch. Pitch is nothing but pitch will be equal to half of it, which is nothing but a 0.5 mm. You should understand that for one rotation, if 2 rotation it is a 1 mm. For one rotation, that will be equal to 0.5 mm. The total number of divisions on the circular scale. Therefore, that is also important to find out a least count. The number of divisions on this are 50. Further, it is found that the screw gauge has a 0. So that's also important. I need to find out a error. He has given it as a negative error himself, right? While measuring the diameter of a thin wire, a student notes the main scale reading is 3, right? So he's given the main scale reading as 3 mm and the circular scale reading as a 35. Then we have to calculate. That was easy, right? Everything was given by him. We have to only find out a least count. We need to calculate only the least count. Therefore, before that we have to find out a pitch. Therefore, we need to find out a pitch. We know the pitch is equal to for two rotation there is a 1 mm. Then for one rotation it will be equal to 0.5 mm. There is no need of calculation. You can directly write it. There is nothing but 0.5 mm. And then we have a least count is equal to, the least count formula, it can be written as a 0.5 by 50, right? 0.5 by 50, that is nothing but pitch by circular divisions. Therefore I have a mm, therefore that will be equal to what? That will be equal to 0.01 mm, that is the least count. That was the least count. Therefore the reading formula, right? Therefore we have a reading is equal to MSR plus we have a CSR, MSR plus we have a CSR, MSR we have a CSR into LC. Since it is a negative error, we have to add it. We have a plus error. Since that is a negative error, we have to add in a value because మీకు వచ్చే వాల్యూ తక్కువ ఉంటుంది because of negative error వల్ల. You know that logic already. So this is nothing but 3 mm plus this is nothing but 35 into 0.01 mm plus this can be written as 0.03. Yeah, do this calculation, you will get answer. So that was a simple question, right? So that's all about this 21. I think I just missed one paper to add here. I will add it later and I will send you again in a group, right? Sorry for that. So next one, this one, that is I have a 22, question number 22, the sum of significant figures for the numbers 23.003, 0.003 and 2.1. Even kid can do this, so hope chesar anukuntuna. But so this is a value. There are how many significant figures? 5, and దీంట్లో 1 and దీంట్లో 2. So 5 plus 1 plus 2, nothing but 8, right? No need to do any extra calculation. So your answer is 8. You can directly go with this. So next one, this one, 23. The time period of oscillations of a simple pendulum T is equal to 2 pi root of under of L by G. Measured value of L is 20 centimeter, known to 1 mm accuracy, and the time for 100 oscillations of the pendulum is found to be 90 seconds using a wrist watch of 1 second resolution. The accuracy in the determination of G in the percentage, that is, so let me see the values. The given equation is this, that is, you guys all know this. This is the given equation, 2 pi under root of L by G. And let's go with this L is 20 centimeter and delta L is 1 mm. And the time is 100, sorry, let me choose other pen. The time for 100 oscillations of the pendulum is found to be 90 seconds, and we have a delta T is equal to 1 resolution, and therefore we have to determine the accuracy in a G. We have to find out accuracy in a G, nothing but we have to find out a delta G. You know the formula, right? Therefore let's see this. I have a let's say logic number 1. The logic number 1 is time period formula, that is T is equal to 2 pi under root of L by G, right? So squaring on both sides, you know all this, but doing it, T square is equal to 4 pi square, I have a L by G. Therefore I have a G is equal to 4 pi square L by I have a T square, right? Therefore this can be written as, I can write it as a delta G by G. I can write as a delta G by G is equal to, I have a delta L by L plus I can write the 2 into delta T by T. I can write the 2 into delta T by T. So this is what, but there is a one more logic. The logic is for 100 oscillations, let's say each oscillation is having a T seconds. For 100 oscillations, let's say the time is T. Therefore let's say I have a T is equal to T by 100, right, for one oscillation. Therefore if I apply this ln on both sides, I have a ln T will be equal to, I have a ln T minus I have a ln 100, right? I have a, this can be, if I differentiate it, I have a delta T by T will be equal to, I have a delta T by T, this will be 0, right? Nothing but in the place of a delta T by T, you're gonna substitute this delta T by T. That will be equal to, I have a delta L by L plus I have a 2 into delta T by T. This will be like delta L is given as a 2, this delta L is given as a 2, right? Let me 22 is 2, right? 20, sorry, it is given as a delta L is how much, sorry, delta L is how much, 1 mm. So this is a 1 mm, let me say this is a 1 mm, this is a 1 mm by have a L, so L is nothing but how much, L is nothing but 20. You have to convert that units also. 20 centimeter this one, plus I have a 2 into delta t can be written as delta t is how much? Delta t is 1 second. So this is a 1 second and this will be 90 seconds, right? So this 1 mm can be written as, this 1 mm is nothing but how much? 1 mm. So 1 mm can be written as a 0.1 centimeter. Therefore I have 0.1 by 20 plus 2 into 1 by 90. And you have to calculate what? You have to calculate a delta g only. So therefore delta g is equal to this into g, right? That's a answer for do this calculation, you'll get answer. That's for question number 23. That's a question number 23. Hope that's clear for everyone, right? Let me clear. Question number 24. Measure of two quantities along with the precision of a respective measuring instrument is A is equal to 2.5 meter per second plus or minus 0.5 meter per second. B is equal to 0.10. You can do this clearly because it is only direct formula based. That is multiplication. You know the multiplication, right? That is multiplication. Delta, you have to find a percentage of error, right? We have a delta A by A. Let's say, or else before that. Already direct formula, that's why I'm not giving you the brief one. Therefore I have x is equal to AB, right? We have a delta x by x will be equal to, we have a delta A by A. Everything is provided, so you can do that easily, delta B by B, right? So do it yourself, you will get an answer just into 100 because we have to find out a percentage of it. Therefore do it. And the density, this can also be done by yourself. And look at the question number 26. So 26 is a very easy, but most probably the start to section has not finished this focal length topic. Therefore that will be tough for you, but sorry, you can easily do this. It is a formula. If you find from focal length, you know the focal length formula, that is we have x1 and x2, that is under root of x1 and x2. Therefore that is a direct formula. You have f is equal to under root of x1 x2 is given as a 400, right? Therefore that will be like under root of 400, that will be equal to 20. Answer. That's answer for this 26. That was easy. That was easy. So this formula will be direct, will be there. Hope you remember talking about a star A batch, because that is a direct formula. Please keep that in mind at least now. Start 2 boys or start 2 poetry section. Right. Question number 27. Geometry bridge, it's also like a direct formula. I think you already done that. 27 and 28. So 28 is as shown in the figure in an experiment to determine the Young's modulus of wire. The extension load curve is plotted. The curve is a straight line passing through the origin and makes an angle of 45. That was make an angle of 45. That's making an angle of 45. So it is making an angle of 45 with the x-axis, and length is given as, this length is given as 62.8 centimeter, and diameter is of 4 mm, and we have to calculate a Young's modulus from the graph. We need to calculate a Young's modulus from the graph. So that was the graph is given. That was the graph which is given. Therefore extension and a load, and I have a 45, and since you know the Young's modulus formula, we already talked about the Searle's method in class. So y is equal to have a f L by A into E, right? So we know that from the graph, this from a graph, right? From the graph you find out a slope of it. The slope can be written as, I have a slope can be written as E by F. We have a E by F is equal to tan 45 is nothing but a 1. Therefore I have a y is equal to, I can write the L by A into, we have a E by F, right? Therefore that will be equal to L by A. You know everything, that is, you know the length, and this area can be written as area of length can be written as pi r square. Therefore can be written as L by, since we know the diameter, pi by, we can write as d by 2. Therefore you can write as d square by 4. So substitute out the value and you will get an answer for this. That's it, right? You know the L value and you know the diameter value, everything is given, and substitute it, right? And 29 and 29 30, they both are easy because this is the direct formula. So substitute them and do it. And if you have any guys any doubt, please send me a message, right? Thank you. Thank you. And still there is a pending of some questions I forgot to add here, so I will do it later and I will send you, right?